Hey there, and welcome to This Explainer. Today, we're going to dive right into what I like to call a scientific detective story. So picture it. Back in 2020, the entire world essentially hit pause, right? The streets were completely quiet, flights were grounded, and emissions just plummeted. Honestly, it was incredibly tantalizing for people to believe that nature was instantly healing. But here's the massive central mystery we are going to solve together today. Did that sudden surface level lockdown actually reach all the way up to the stratosphere? Did it really impact the recovery of the ozone layer? We're going to use some first principles thinking to break this all down. And we're not just doing this to answer the question, but to figure out how scientists actually evaluate these super complex cause and effect relationships. Okay, so here's our game plan for today. We'll kick things off with a big ozone question, we'll build out the causal chain, learn how to separate a true signal from background noise, hunt for a scientific fingerprint, and wrap up by learning how to think exactly like a scientist. Let's get into it. Section 1. The big ozone question. Correlation versus causation. Our absolute first hurdle here is asking why we should even try to connect a rapid, sudden policy response to a planetary recovery story that's literally been unfolding for decades. Let's actually compare these two environments, because at first glance, COVID lockdowns and the ozone layer belong to totally different worlds. Down here on the ground level, we have rapid, highly visible changes. Traffic plummets and city smog clears up in just a matter of days. But meanwhile, way up in the stratosphere, the ozone layer's recovery is shaped by incredibly slow chemistry, sunlight, and long-term global regulations. These are entirely different systems operating on completely different scales. So the real challenge isn't just noticing that things got quieter on Earth, it's figuring out if that change actually translated to the stratosphere. To kind of wrap our heads around this, think of a really bustling part of a major city. Now imagine a local power generator shuts down for just a few hours. You would definitely notice the immediate effects on that specific street, right? The lights go out, the fans stop spinning. But a localized disruption like that doesn't automatically mean the entire city's main power grid has fundamentally changed. Different layers of any system just respond on different timescales. A super visible disruption at the surface simply doesn't guarantee a detectable shift miles and miles above our heads. Moving right along to Section 2, building the causal chain. What would have to be true? This is where we get into the absolute core logic of the scientific method. Because, look, a headline is just a story. But a scientific claim? That is a rigid chain of connected ideas. So if lockdowns genuinely impacted the ozone layer, a very specific sequence of things must simultaneously be true. Number 1, the lockdown had to change the right kind of emissions, not just general pollution. Number 2, those specific emissions had to actually alter the chemistry in the stratosphere. Number 3, the atmosphere had to respond on the right timescale. And 4, that response had to be significant enough to rise above the planet's national noise. If even a single one of these links fails, the whole theory just completely collapses. Let's talk about that first link, changing the right emissions. Why is that so crucial? Well, think about plumbing. Lockdowns absolutely cause some emissions to drop, no doubt. But closing the kitchen tap doesn't suddenly change the water pressure in your upstairs bathroom. It depends entirely on how the pipes are connected. Or think about making tea. If you want the water to boil differently, you have to adjust the flame under the teapot. If you just quiet down the people talking in the kitchen, the tea literally doesn't care. The system only responds to the inputs it was built to sense. And what about that timescale link? Human nature makes us want things to act like a light switch. You flip it and boom, instant result. But the atmosphere, it behaves way more like a giant pot of soup. If you toss in a handful of salt, the taste doesn't change perfectly everywhere all at once. You gotta stir it, you have to wait, and let that change spread slowly. For a sudden lockdown to impact the ozone, the timing of that atmospheric stirring would have had to line up perfectly. All right, Section 3, signal versus background noise, finding the truth in the churn. This is arguably the absolute toughest challenge scientists face, detecting one real change in a system that is already churning with wild natural fluctuations. Here is the thing. The ozone layer is naturally incredibly noisy. It changes from season to season, pole to pole, year to year, all thanks to temperature shifts, winds, solar variations, and even volcanoes. So even if something did shift in 2020, scientists have to ask, is this a genuine lockdown effect or just the Earth doing its normal thing? It's exactly like trying to pick out one specific voice in an insanely crowded, noisy market. Even if that person talks just a tiny bit louder, you still might miss it. The signal absolutely has to pierce through all that background chatter. So how do scientists actually isolate that signal? They use a bunch of different types of evidence, but, and this is wild, every single one has a massive blind spot. Satellites can tell you what happened up in the air, but they totally miss why it happened. Emissions data shows us ground-level drops, but misses whether those gases ever actually reached the ozone. Chemical models prove if an idea is plausible, but they aren't a perfect mirror of reality. And long-term records? They prove 2020 was an unusual year, but they can't definitively point to lockdowns as the cause. See how a single clue can easily lead us astray? Which brings us to Section 4, hunting for a fingerprint, triangulating the evidence. Because those single clues are so flawed, scientists never just look for a convenient before and after coincidence. They are hunting for an overlapping footprint, a definitive fingerprint. This is the sharper question I really want you to start asking. Does the whole pattern match the cause? Relying on timing alone is a total trap. It's like hearing the school bell ring at the exact millisecond the power comes back on and thinking, wow, the school bell fixed the electricity. Coincidental timing is just not enough evidence. A true scientific fingerprint needs multiple points of connection. Imagine hearing a muffled song playing through a thick wall. You probably won't catch every lyric, but to confidently name that tune, you need the rhythm, the melody, and the sequence of notes to all line up perfectly. Just one matching note means you're guessing. Science is exactly the same. The emissions data, the models, and the actual observations all have to sing the exact same song. And in the case of our 2020 mystery, this is where the case breaks wide open. While ground pollution plummeted, the stratospheric data just didn't complete the song. That drop in surface traffic had basically zero immediate impact on stratospheric ozone, because ozone recovery is actually driven by complex temperatures and long-lived chemicals, not a short-term dip in city smog. Let's break down how this works in practice. If emissions changed but the ozone didn't, well, those ground changes didn't matter to the stratosphere. If ozone changed but the models disagree, it usually means some other natural cause is way more likely. If the pattern only shows up for one single year, it's probably just that normal market noise we talked about earlier. Scientists are relentlessly chasing that bottom row, where multiple, totally independent data sets all converge to show the exact same unusual signal. That is the only way you build a credible case. Section 5. Thinking like a scientist. The aha moment. We've officially reached the climax of this explainer. Ultimately, testing causality means separating what actually happened from what should have happened if the cause was truly real. Think about the analytical toolkit you've just built up. You can now evaluate big claims without getting swept away by flashy headlines. You know you have to find the actual linking mechanism. Remember the pipes and the teapot. You know how to untangle pure coincidence from a true explanation. And, maybe most importantly, you now understand that an effect can be totally real, yet so incredibly tiny that it just vanishes in the natural noise of our planet. This really all comes down to one massive mindset shift. When we look at complex systems, we absolutely have to stop asking, could this possibly be true? Lots of stories sound perfectly plausible. Instead, we need to be asking, what would have to be true for this to be true? That is the gold standard. That is what separates a catchy story from rock-solid, evidence-based reality. So I'm going to leave you with this final thought. How are you going to apply this new scientific lens to the next big viral headline you see? Next time a crazy global event claims to have instantly altered nature, you now know exactly what to look for, what to question, and exactly what kind of evidence you need to demand. Thanks so much for hanging out with me for this explainer, and keep asking those right questions.